Hello everyone. So let's solve today's LeetCode POTD. Count special triplets. So the problem states that we are given an integer array nums, and now a special triplet is defined as a triplet of indices I, j, k, such that all these indices lie in the range of 0 to n minus 1, and we have nums of I is equals to nums of j into 2, and nums of k is also the same as nums of j into 2. Now, out of all possible triplets, we need to return the total number of special triplets in the given array. And since the size of the array can go up to 1e5, so hence there can be like n square, n cube triplets possible approximately. So hence, like it can go up to 1e15. So if it goes beyond means integer values, we need to return it modulo 1e9 plus 7. Okay. So let's see the given input. So what do we need to do? We need to find such indices I, j and k so that if x equals to nums of j into 2, then this value should also be x and this value should also be x. Okay, so we need to find such triplets. For example, here we had 3. So x will be 3 into 2 equals to 6. As you can see, like on the left we have a 6, on the right also we have a 6. Hence, these 0, 1, 2 indices will form a valid triplet, and hence the output here is 1. Let's see another input. So here we can make 0, 1, 2, 3. So we know like multiplying 2 by any means 0 by any number will still remain 0. So if we choose x as this, so x will be 2 into 0 equals to 0. As you can see, like on the left we have this 0 and on the right we have this 0. So a triplet will be formed of these indices, and hence the output here is 1. Let's see a different input. So we have like 8 and 8 here. So we need a 8 in the between. Okay. So we can make it by multiplying into 2. So x here will be 4 into 2 equals to 8. And hence we have 1 8 on the left and 1 8 on the right. So we'll have 0, 1, 2, 3, 4. So the indices 0, 1 and 3 will form a valid pair. Apart from that, we have 4s and 4s. So we need a 4 in the middle. So as you can see, like we can make this 2 into 2 as 4. So hence the indices 1, 2 and 4 will also make a valid pair, because nums of 2 into 2, which is 4, is the same as nums of 1 and nums of 4. Hence the output here was 2. So what will be the brute force approach for this problem? Then we simply need to find the number of triplets. So we can traverse through all possible triplets and see whether our condition is satisfied or not. So what we'll do, we'll simply move I from 0 to n minus 1. Then move j from I plus 1 to n minus 1. And then move k from j plus 1 to n minus 1. Now at each step what we'll see like if the mid value is nums of j into 2, then we need to see whether this nums of I should be same as mid, as well as this nums of k that we have should also be the same as mid. Okay, so if this condition is satisfied, then we'll simply update our means total triplets count by 1. And if it means we will have a mod. So if at any point it reaches a value which is beyond this, so we'll simply need to make it result percent equals to mod. Okay, so that it still remains a remainder of this value, because we are asked to return the, since the answer may be large, we need to return it modulo 1e9%. So this will be the brute force approach, and obviously like this will take a big of n cube complexity, because of means we are traversing through all possible triplets, and as you can see like n can go up to 1e5. So this approach will definitely give us daily. So let's see the approach in a form of code. So we have the defined a long result. Now we'll iterate through all possible values of the triplets. Then we define this mid, and if this mid is same as nums of I and as well as nums of k, then we'll update our result and update the result with mod and finally return the result. And this will be giving us daily here. Okay, so like how we'll be optimizing this algorithm. So whenever we are like asked to find triplets or pairs which satisfies some condition, we try to rewrite the formula to means see whether using just a single index we'll be able to calculate the result or not. So what do we try to do? We try to means rearrange the formula, then try to see if can be solved using a single index only. Using a single index only. This is what we generally try to do. So the formula that we have here is nums of I equals to nums of j into 2 equals to nums of k. Okay, so this is what we need to satisfy. So if mouse, now what indices can we move through? Either we can like try to satisfy the condition for picking a particular I and then try to see whether these j's and k's exist on the right. One thing we can do that. Other thing that we can do is move through j, or we can do move through k. Okay, so moving through what index would be feasible and like easily help us calculate the result. And now we know that n can go up to 105, hence we like definitely need to do it in the order of n or n log n. Okay, so hence we are only allowed to like do a single pass over the array. We cannot account for all possible pairs of ij or jk or ik like that. Okay, so let's try to like see if we iterate through I from 0 to n minus 1. Now what is the problem here? The problem here is we need to find j's on right such that what? Such that this nums of j is equals to nums of I by 2, and as well as this should be like, and this nums of I should be even so that it is perfectly divisible by 2. Okay, so this is means nums of I percent 2 should be equals to 0, right? And then we need to find case on right of j such that nums of j equals to nums of I. Hence we need to find the number of values on the right which are same as the nums of I, and we also need to find those j's which lie before a particular nums of k and its value is nums of I by 2. So this is like appearing to be a pretty hectic because we need to solve two different problems here, nums of I minus 2 as well as nums of I. So let's try to iterate through j, okay, and see like what values do we need to calculate. So if we iterate through j, what do we need to find? So if our current value is nums of j into 2, okay, this is the current value. Now what do we need to find? We need to find number of i's on left whose value nums of I is equals to current. Means we need to find the number of indices on the left such that who has the same value as current, right? And along with that we need to find number of k's on right whose value nums of k is also current. That means we need to find the number of i's on left whose value is the same as current, as well as we need to find the number of k's whose value is same as current on the right. So, and when we find, so suppose the equation was we have 8 4 4 8, okay, or let's say 8 8, okay. Now this, for this 4 we have like the current as 2 into 4 equals to 8. Hence on the right, for on the left we have one value which is equals to 8, and on the right we have two values. So now how many triplets will be forming here? We need to see. So to account all possible triplets, that means for each index on the left, we'll be making a triplet with all the values on the right, right? Hence for this 8 we will be making it as a part of triplet with this, then another triplet with this. Hence if it had been like this 8 8 4 8 8, then for this 8 we would have make it a triplet with this as well as this. Then for this 8 as well we will have make a triplet with this as well as this. So hence we see like for this current, the number of pairs, number of triplets will be increasing by what? The count of number of elements on the left into the number of elements on the right to account for all possible possibilities. So at each step we'll find the current, and the current will be nums of j into 2. Now we need to find the number of values on the left whose value is same as current, and the number of values on the right whose value is same as current. Now this like appears to be, here we only need to solve a single problem, means the value remains the same. Here we are needing to find out nums of I by 2 as well as separate, means check this condition as well, and then also need to find nums of j, means nums of j as well. So which approach was feasible here? As you can see, like since we only need to deal with a single value current here, so maybe iterating through j is more optimal than compared to iterating through I. So once we identified that, then we try to see what values do we need to calculate. So if we are able to find the number of values on the left and the right which are same as nums of j into 2, then we'll be able to simply calculate the number of triplets at for this particular j by the number of means left into right. Okay, so what we can do is we can iterate through all the j's. We can iterate through all the j's. Then for the current value nums of j into 2, what do we need to find? We'll simply like left, we need to find this left and we need to find this right, and then what do we need to do? We need to simply increase our triplet by left into right. Now finding this left part might seem simple, like we can simply create an unordered map of int, and we can simply like left, and we can simply like keep track of the number of, means we can simply keep the frequency in a running fashion. So if we started the loop from j till n-1, so once we have done the calculation for this particular j, we'll increase our left of nums of j by 1. That will mean that for the next iteration, the means we have updated this nums of j value. So in future, if this is required as current, means current is nums of j dash into 2, if this is value is the same as this current, then we are able to get its count on the left. Okay, now comes the case like how we'll be able to find the number of elements on right. So definitely like we will need to do some pre-computations to be able to calculate it. So we'll be following the same approach we did. So we created a unordered map to keep track of the number of frequencies of each number till j minus 1. If we are at particular j, we keep track of the frequencies till indexes j minus 1 for each value. Okay, now we need the values, means we need the frequency for j plus 1 till n minus 1. So what if we initially create this map which has like all the elements in it, okay, which has the overall frequency, means it has for int x nums, it has like all the values. Now how I will be calculating it? So if we are at a particular j, suppose j equals to 0, so what we'll do to find the means frequencies of all elements from j plus 1 till n minus 1, we need to simply reduce the frequency of j here. And if we keep reducing the frequency of j's as we move right, then the remaining frequencies will be from the indices j plus 1 till n minus 1 only. Hence the first step that we will do is write of nums of j minus minus. Okay, and then we'll do the calculation, and then in the end what we'll do, we'll increase the left of nums of I, and in between we'll see like whether the current that we have is nums of j into 2. These values will multiply both values, its count, means left of current into right of current. So I hope you are able to follow like how we try to rearrange the formula. Then on the basis of a single index only, we try to identify like, since j only need to deal with a single value, so we'll be iterating through j only, and iterating through j will simply need to find the same values, number of values on the left as well as number of values on the right. For number of keeping track of the number of values on the left, we simply make a unordered map left, means which will have the prefix frequency, and to find the suffix frequency we create the overall map and then keep decreasing its count as we move forward, so that we only have the frequencies for the indices j plus 1 till n minus 1. Okay, so this will be the overall approach for this problem. As you can see, like we are iterating through j only once, and we are creating this left map which is unordered map, so the overall complexity would be big of n only, and the space complexity would also be big of n. Okay, so this will be the approach for this problem. Let's see the code as well to get a better understanding. So we simply create a right map. Okay, so we can create a right map and update all the values in the right map. Now we'll be creating this left map, and this is the mod value that we need to take mod with at each step, and this will be the result. We have initialized this long so that if it value become greater than 189 plus 7, we can simply take the mod. Now we move through j. At each step, the first step will be to reduce this nums of j, so that we nums of j means this right will store the frequencies from j plus 1 till n minus 1. Okay, and left already has the frequencies till 0 till j minus 1. So hence we can simply find for this j. So we see like if this nums of j into 2, which is the current value, is present in left as well as it is present in right, then we simply multiply both of these two values and update our result with result plus this we have done, so that if this value is long, so it does not give integer overflow. So one I will make sure that the result that we get from here is long. Okay, so we'll update our result with this and take mod at each step, and in the end we'll simply increase left of nums of j, so that now we have the left stores frequencies till this, and for j plus 1 we have the left as this, and then again we'll be decreasing the count of right of nums of j plus 1 in the next step. So this will be the approach, and we simply return the result. So as you can see, like this is of the order of n, and the space required is also of the order of n. So this was the approach for this problem. Let's try to submit the code as well once. So this is like the brute force code that we have. So let's try to submit it and see whether it's give TLE or not. Okay, it will be simply result. As you can see, it runs fine, but let's try to submit it and see whether it gives TLE. And as you can see, it is taking a long time, and yeah, it gives means TLE here. So let's try to submit the optimal code as well. Yeah, so this will be the optimal code. Let's try to submit it in this case and see like how many ms it takes to run, because it is of the linear complexity, and as you can see, like it beats 87% of the solution, which is like fair enough. So this was the overall approach for this problem, and I hope like you are able to follow and you will be able to use this similar approach of rearranging the formula and then trying to see which means iterating through which index will be helpful. And once we identify that, then like implementing it is a separate concern. So yeah, I hope you are able to follow along, and if you did, make sure to like, and if you have any doubts remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.